inside the data, we have patient ID. So those is our numbers, but it's just the unique ID assigned to each patient. And diagnosis type, and we also have numbers. So from the filter, you can see it's 1, 2, 3. So each number present a type of chronic disease. So 1 can be diabetes, and 2, heart failure, and 3 will be certain lung disease. Okay? And we have age, and this one is numerical. So 21 really means the age years, 21 years old, right? So you can see the range, and actually from 21 and up to 109, amazing, right? So that's age. And gender, definitely categorical. So here it's binary, so only male, female. And we have age group. So here we have numbers, but they are categorical values. So 1 means younger, and probably under 45. And 2 will be 45 to 64. And 3 will be above 65, right? And whether a patient living in rural or urban area, so yes or no. And insurance type, we also have value 1, 2, 3, but there's also categorical value. So 1 can be Medicaid, 2 Medicare, and 3 is Medicaid and Medicare. Right? And then finally, our dependent variable, so telehealth experience. So here we only have 2 values, and that's 0 or 1. So 1 means yes, and 0 means no. So whether the patient had telehealth experience during the period, so 1 means the patient had, and 0 means the patient didn't. So the data set is quite simple, and to conduct logistic regression analysis, so this time unfortunately we cannot use like Excel. Right? We probably still can use Excel, but so we need to do manual calculation, multiple steps. So we need to calculate the log value and do some transformation. So that step can be really tedious. So that's why we need to use GMP. So this is a quick, easy feature in GMP, and we can just plug in, and then we can have the logistic regression. Right? So on your side, and you don't need to know how to calculate the log value, how to construct the logistic regression, give the log values. Right? So similarly, you don't need to really manually calculate like standard deviation or p-value. But very important, you need to understand so how to construct a regression models. So what's the dependent variable, what's the independent variable, and what's the meaning of a standard deviation, what's the meaning of a p-value and the coefficient. So in JUMP or GMP, and you simply click File, click Open, and you locate this Excel file and click Import, and then you will get the data set, or you click Open. So they were going to import this Excel file, and you simply look at the header or label and make sure there's no mess up with the variable and within this data set. Right? So look like everything is fine, and then you can simply you can try to click next. There's more options. That's only useful when that's not appropriately and to import data. For example, sometimes you separate the data with comma or space, so you need to use a different step and to import data. And for Excel, most time it's easy, and you see the data import on the preview of the data and looks fine, and you can simply just click import. So once you import the data, we need to do some additional steps. So the reason we need to do some additional step is, as we discussed before, so some value in this data set showing as a numerical, like 1, 2, 3, right? But we know it's a categorical value. So 1 doesn't mean the +1 will be go to 2 and diagnosis type 2. So there's no meaning, you do some calculation. So that is not a numerical value. It's a categorical value. So that's why, so we need to tell GMP, so those are categorical value. So don't treat it as a numerical value. Otherwise, they will treat it as a numerical value, and then they will think 1 and incrementally +1 will be 2. But in this case, so diagnosis type 2 is not a 2, diagnosis type 1, right? So not make sense. So that's why you need to manually and indicate they are categorical values. Okay? So how to do it? So you can click diagnosis type and click the right button of your mouse, and then click column information. you can see the diagnosis type, the pop-up window, right? You can keep a data type as a numerical, but the modeling type, so the modeling type is a nominal. So nominal means categorical. So make sure you select a nominal. So then this will be treated as a categorical. So I will continue doing this. So gender, actually, you don't need to do it because the value is showing as a character or letters. So whenever it's a character or letters or string, the GMP will recognize it as a categorical or nominal value. Okay, so we don't need to worry about this one. And going to age group. So here we have 1, 2, 3, and we need to explicitly indicate, and they are categorical. So here again, so click the right button of the mouse and go to age group, right? So column information, age group. So here modeling type, and you need to change to nominal. And for rural, we don't need. So it's a letters character. So GMP will know it's categorical. And insurance type, we need to do it. So column info and modeling type, and click nominal, and click OK. And our outcome variable or dependent variable, so definitely we need to make sure and tell GMP this one is a nominal. It's categorical, right? So you click OK. So now we finish this step, necessary step, indicate those which value and which variable is a categorical variable, and don't treat those numbers as a numerical value. Treat it as categorical values. So now we are ready. So next, and we can simply use the built-in feature in GMP to do logistic regression analysis. So that is quite quick, easy. So what we need to do is go to analysis. So click analysis on the top, and there's a lot, right? A lot of technique we can use. So certain thing we can use later when we do cluster analysis, we do machine learning, right? So here we just do a very simple one. So click analysis and click fit model. So we have a model to fit. So here we have a logistic regression model to fit, right? So if you want to use GMP to conduct some linear regression analysis, you can do it the same too. Just make sure the dependent variable, independent variable, the dependent variable is numerical, right? So you can use a linear regression. So click fit model, and in the pop-up window, and you need to assign the dependent variable and the independent variable. So here, as you know, so Y will be dependent variable, and which will be the telehealth experience, right? So you click telehealth experience or highlight telehealth experience, and then click Y. And what you can see here, so the personality actually is like a model type, right? So I don't know why the GMP called the personality, but it's literally the model type. So things we already define or indicate telehealth experience is a nominal or categorical variable. So when you add a telehealth experience, and they will automatically select nominal logistic, because they know it's a binary outcome, 0 or 1, which means yes or no. So they won't automatically select like other like linear regression models or generalized regression models. So if I remove this one and see, we still have numerical, so like age, right? So it's with a numerical value. So if I add to Y, you can see they just use the least square method, right? So which is the linear regression method, right? So the data type or variable type and can be really important, and when you select different models in GMP. So here, let me put tele experience as the dependent variable. So this one will be fine. We are going to use logistic regression. And then our independent variable or factors, and I will use just the age and the gender as example. Okay. So for other variable required in the assignment, so I will leave to you and to add those variables and to see their their impact on telehealth experience. So actually, I wanted to use not even gender. Let me use a diagnosis type. So I will use age, and diagnostic type. So you know diagnostic type is categorical. So 3 types of diagnosis or disease. And age is numerical. So age 21 to 109. Right? So that's simple. So that's a simple model. And then I will click run. So in the result window, and you can see the results. So here you can see, for example, the p-value. So p-value, age, and the diagnostic type, and both showing less than 0.05. So that means, yeah. So those two variables or two factors have significant impact on telehealth experience. So moving forward, this is the general model fit. So it's less than 0.01. So that means it's significant fit, right? And for others, and let's look at the parameter estimates here. So look at the parameter estimates, and we can see age and showing significant, right? So it's less than 0.01. So that means the age so estimate is negative. So that means a negative association with the telehealth use. So what we can interpret here with a negative and means when age increase and the telehealth use and will go to opposite direction. So will be means a decrease, right? So what we can interpret here is when the patient age increase and actually the likelihood of the out and patient will use patient had telehealth experience and actually will decrease. So this is the coefficient negative 0.01. And remember, and in logistic regression, the coefficient is actually the log value. So it's very hard to interpret. And that's why in logistic regression, we always use the odds ratios to interpret. So I will show you the odds ratio result and see how we can interpret it. But let's look at the diagnosis type. And diagnosis type, you can see here, since it is a categorical variable, right? So we have 3 levels, 1, 2, 3. So whenever you have categorical variable with different levels, and logistic regression will show in comparing a base level. So how are the level different from the base level? So here you can see diagnostic type 1, diagnostic type 2. So that means the base level, the model select is diagnosis 3. So the difference showing significant. So here, so type 1 comparing to the type 3 and the different, and we can see the moderate significant. So if we have a cutoff value 0.05, so it's a little bit larger than 0.05. So this one means comparing to diagnosis type 3 and patient with a diagnosis type 1 and is more likely use telehealth experience because the estimate or coefficient is positive. And here, for diagnosis type 2, and we have the p-value 0.079. So for cutoff 0.05, if it's our significant level, and that means diagnosis type 2 is not a significant different type, diagnosis type 3, in terms of high telehealth experience. So this result can show, so at least you know which factor our group is significantly different from each other. And also look at the coefficient, given whether it's a positive or negative, so you know, so what's the association, whether it's positively or negatively. But to interpret the coefficient or quantify the impact, and let's look at the odds ratio. So to find the odds ratio, and what you need to do is click, you can see here, nominal logistic fit for telehealth experience on the top over here. So you need to click this smart button, and then you see there's a drop-down menu. And among the drop-down menu, and you can see the odds ratio. So simply click odds ratios. And now we have odds ratios showing here. So let's look at the age first. So this one is a per unit change. And that means age change every 1 unit. That's 1 year older. So given the odds ratio, so in here, 0.986. So given this odds ratio, so that's you can interpret. So for patient's age, so every increase like 1 year old, and the likelihood of the odd, the patient will had telehouse experience and will be 0.98. So that's smaller than 1. So that means less likely. Or you can use 1 minus 0.98, and you can interpret as so when patient's age increase 1, and the patient will less likely 2%, 1 minus 0.98, so will be 0.02, so 2%. So the patient will be 2% less likely had telehouse experience. So that's its only increase, age by 1. So gradually, when age increase more, and you will have, more percentage less likely to have telehouse experience. So far, for age increase 1, and patient will be 2% less likely and to have a telehouse experience. Okay, so let's move on to the categorical variables, diagnostic type. So here, we have 3 diagnostic type or 3 type of disease. And then we have the 3 group present 3 type of disease. And those odds ratio and only show this between the group. So here we have the reference. We have the reference group 1 by 1. So now we can see, let's see, first, you need to see the p-value. So we should only interpret and the coefficient which has, the significant p-value, which means less than 0.05. So now let's see the p-value here, and we can see comparing to 3 and 1. So when 3 compared to 1, and we have a significant the p-value 0.01. And now the odds ratio, and we can see is 0.92. So which means so comparing to like patient with the diagnosis type 1, and here the patient with diagnosis type 3, it's 8% less likely had telehouse experience. So here the 8% is calculated from 1 minus 0.92, which is 0.08 and 8%. So here, so level 2 is a reference level. So this one is for patient with a diagnosis type 3, and comparing to patient with diagnosis type 1, and they are 8% less likely had telehouse experience. And the next one, let's see, is also significant. So that is the patient with diagnosis type 3 compared to patient with diagnosis type 2. And the p-value is less than 0.05. So this type, the odds ratio is 0.91 or 0.92. So if we round up to 0.92, so that's the same thing. So patient with diagnosis type 3 are 8% less likely had telehouse experience compared to patient with diagnosis type 2. And for others, and this is 3.1, 3.2, and here, so when you see 1.3, 1.2, actually it's the same story. And just the odds ratio will be reversed, right? So when you have, see here, 0.92, and you use 1 minus 0.92, you get 8%, so less likely. And then when the reference level is 3, and now you talk about patient with diagnosis 1 over here, and then you can see it's a 1.08. So minus 1 is 8%. So now you can see patient with diagnosis type 1 are 8% more likely had telehouse experience compared to patient with diagnosis type 3. So those is the same thing. So if you compare a base group, less likely have lower, then you just 1 minus this value. And otherwise, and when you look at the 1 comparing 3, 2 comparing 3, you use odds ratio minus 1. Okay? So that's how you look at the logistic regression result and see the odds ratio, see the p-value first. Right? Same as when you look at the linear regression result, you check out the p-value before you want to interpret the coefficient. So you can also look at the confidence interval. And one thing you can see whether the association or impact is significant or not. And basically, you also can get it from the confidence interval. So normally, if the lower bound and the upper bound of the confidence interval cover 1, and then, so that relationship won't be significant. So for example, here you have p-value 0.9, and then you can see, so the lower bound and upper bound cover 1. So when you have p-value less than 0.05, relationship is significant, and you can see not cover 1. So this is not cover 1. And when we have odds ratio above 1, and you can see the lower bound and upper bound both above 1. So not cover 1 means the association is significant. So again, you go to the small button next to the normal logistic fit for highly experienced over here on the top. So when you click, and you can see this one called profiler, right? So it's a build a profile based on the logistic regression model. So click profiler, and you see at the bottom, and you have a figure. So when you click along the line, and you can see showing different values. So keep diagnostic type 1, and let's see what's the impact of age. And when the really young patient sees the age 20, so the odd will be 0.63. And then you move to 40 years. So odd will decrease, right? 0.582. And then let's move to 60. So 0.524. And when you move to 100, the odd can be really small, right? So that's only the 0.392. So now let's keep the age. Let's see, keep age 40. And then comparing to, so patient with diagnosis type 1, and that's a 0.577. And you move to type 2, so not much change, right? At that age, not much change. And you go to diagnosis 3, so little change, so very small change. So here, we probably can see the impact of age, and actually is stronger. And the impact of diagnostic type and be actually smaller. But even the actual value is smaller, the impact in terms of the statistical significance, and which is significant. So actually, no, for the assignment, you need to import data into GMP, and you need to indicate the data type or the modeling type of each variable. And some you need to manually indicate, those numerical value actually categorical. For example, the diagnosis type, the age group, and the insurance type. So here in the data type, so age group will 1, 2, 3, but it's categorical. So it's the age above 65 or between 44 and 64 or under 45, right? And then for insurance type, the same thing. So 1 to 3 each present Medicare, Medicaid, or both. Luckily for gender and rural, the two variable things that they have the letters as a value. So GMP can automatically detect those are categorical variables. But for others with a numerical variable, you need to manually indicate they are categorical variable. So you need to go to the column info and indicate the modeling type is a normal. So normal means categorical. So then you need to select the dependent variable, which is a telehealth experience, yes or no, 1 or 0, and select your independent variable. So for your assignment, your independent variable are age group, gender, insurance type, and rural. And then you click run, you will get the result. So you have your result, but for your assignment, you need to communicate your result to your audience. So that means you need to discuss or interpret the results. So here, I want you to discuss with the p-value, and you need to interpret the odds ratio, right, based on the odds ratio, and discuss what's its impact. So I have some discussion in the template, and you can use it as a reference. And make sure and follow the format and to format your report.